right, guys, girls, happy day. There was a quiz yesterday. I graded them. Some of you didn't get quite done yet, but you will. And for the most part, I'm like rock on. You guys, I think overall did very well. So congratulations. If you missed the quiz, you need to come make it up. Let's see my schedule today. My schedule today is I have a meeting at Eagle Crest at 10. Probably gets done. Be back here by 11:30, and then I'll be in my office from 11:30 to 3 for the most part. And then tomorrow, right after this class, I have a meeting until about noon. Tomorrow might be a goofy day because that's Friday, right?
No.
It'll be a good day, but it'll be a goofy day as far as schedules go. So if you did, next week we'd probably be able to open up a little bit more time. So I'm gonna kind of go through what we've worked on, and then I'm gonna show you how a quadratic gets to vertex form. You don't need to know how it gets to vertex form. I just want you to see how the process works. I imagine in your Algebra 2 class when you take that, not this coming year, but the year after, but Ray, it'll be you next year, right? You have Algebra 2 next year? Okay. I'm going to show you the method that's used in order to put it into vertex form. So what we're going to do is you're going to see it in the forms we're in, and then we're going to go to vertex form, and then I'm going to show you how it went from our original form to vertex form, but you don't need to know the process. I just want you to see the process because it's important for me to know, for you to know. So I want to, there's a front and a front. I'm sorry I wasted paper today. I tried to put enough notes on people's desks. So go to the sheet that says review of what we know so far. Review of what we know so far. And let's put this equation up. Okay? What I got? Okay. So I'm pretty sure 90% of you could look at that and say it opens down. And then the other 10% are going, oh yeah, that's right. Good shot. So when we go utilize this type of problem, what we tend to do is we go through and we find the vertex first. The vertex, we know that this is our A value, this is our B value, this is our C value. Our vertex is going to be negative B over 2A. Then plug in. So it's going to give me negative 8 over negative 4, which is 2. And then I plug 2 back in, and I get to here and here. So that's going to be 2 squared, which is 4. Excuse me. 4 times negative 2 is negative 8. Plus 16, because 8 times 2 minus 1. Negative 8 plus 16 is 8. 8 minus 1 is 7. So I find I have a vertex of 2, 7. Axis of symmetry is x equals 2. I get a, being this opens downward, I will have a max at 7. Okay? So those are some things that we definitely know so far. So 2, 7. And our pattern graph, yeah. Thanks. That's an x value right there. So you plug x in here and here. You do the arithmetic. So 2 squared, 4. 4 times negative 2, negative 8.
Oh,
okay. And then we know that it's a max because it opens downward. We know it opens downward because it's negative. Our pattern graphing won't be 1, 3, 7 or 1, 3, 5. Excuse me. It'll be negative 2, negative 6, negative 10. We don't always have to use all of that. So for my vertex, I'm going to go right 1 down 2, left 1 down 2. Those are obviously points that we could identify pretty easily. And then I could even go a little bit further. I could go from that. I can go right 1 and down 6. So right 1 and down 6. So 1, 2, 3, 6. And left 1 down 6. So we get our parabola. It should be a little straighter. Things that you can identify about the parabola: it opens down. That's a maximum value we just talked about. Our max value is 7. It's other things that we know about it. It's increasing from on this side, so from negative infinity up until the x component. So it's increasing from negative infinity all the way up to 2. Rounded bracket, because remember, the very top when we get to 2, it's not increasing nor decreasing. It's just going to be a horizontal line. Let's see. What else do we need to know about this? It looks like our roots, it does cross the x-axis twice. It more than likely would not factor out. My magic number would be positive 2. The factors of positive 2, because I'm going negative 1 times negative 2 on the factoring. Positive 2 is positive times positive or negative times negative. I can't combine any of those together being positive, both negative to give me positive 8. So it's not going to factor. So these are called irrational roots because they cross the x-axis. It's just we don't know exactly where they do. We know approximately, not exactly. So that's the in and out of this problem. Okay? Now, every problem that you're going to see here in this class, you can do this way. Something that you might want to start thinking about is if you have the graphing calculator, and I'm going to walk through it. In no way, shape, or form you're going to become a pro at it. But if you have one, cool. If you don't have one, you can still do it by hand. And then you'll wonder why those who have it get done quicker. So I'm just going to walk through it quickly. I'll give you some more time to go through them. So most of the time you can go y equals. If you have things that are in the y equals, you need to clear them out. It looks like I actually have a stat plot on, so I need to go up to the very top and make sure that is off. So just hit enter. And then if I plug my first equation in, it's negative 2x squared plus 8x minus 1. And just some tools that come across. If you hit graph, oh, looks like my graph is goofy. I'm going to have to go zoom until that's done thinking up there. So I have to go zoom standard. So zoom number 6. Yep. And it should draw my parabola. Lo and behold, that looks kind of similar, a little neater, but kind of similar to what I had drawn there. I got the color the same. All right, things that you know, this will tell you how to find the zeros. This will tell you what the maximum is. You just have to know which button combination to push. So if you go second calculate, you wanted to find a maximum value, it's then going to give you this cursor. And we're going to move the cursor to the left and to the right of where we think the maximum would be. So it's somewhere up there. If I enter, I don't want to guess. I would like to know. And it shows us that our vertex is at 2, 7. Okay? Why does it way out here on the decimal show us 2.17? Does anyone know? It's not being precise. We're more exact than our drawing, actually. So Texas Instruments, the calculator, have pixels, and pixels are normally square, except for in the world of Texas Instruments. They made them rectangles. That's why there's a little bit of margin of error that's taking place on this. Okay? So, that's really, so you can rest assured that our vertex is at 2, 7. If you were given this on the test, if you wrote 2.00017, 7, good for you. They're actually wrong. The calculator is off slightly because they use rectangles versus squares. Not sure why. Maybe they were cheaper. Other things to do, it'll do second calculate. If you wanted to find a 0 would be the same thing as a root. So you have to make sure you go underneath and above the line of the x-axis. So if I go underneath and above it, hit enter. No, I don't want to guess. I want to know. And at about 0.129, it's crossing the x-axis. If I wanted to find where it's crossing here, you do the same thing. I'm going to go second, calculate. I want a 0. And I'm going to take this. I need to be above and below it first. So be above it first, and then go below it. And below it means the x-axis. I don't want to guess. So it looks like at 3.87 roughly is where it crossed. And again, those are irrational roots. We couldn't find the exact value. The calculator is going to take it out at only so many decimals, and then it knows to truncate off. But that's how the calculator knows how to work through these. Okay? Good so far? Guys and girls, there's no way, shape, or form I'm expecting you to be an expert on that calculator. So, you are good. Another type of problem we saw, we might have seen a problem like this. Okay, and this one, it's harder to find the vertex, but we know the roots. Agree? Make sense? So we're going to find the roots. Basically, I take each of the binomials and set them equal to 0. So I get x plus 1 equals 0, x minus 5 equals 0. And so that gives me x is equal to negative 1. This gives me x is equal to positive 5. So at negative 1 and at positive 5, I know the exact roots. Okay, this one happened to factor down. They gave you the factored form. They factored out a greatest common factor of 3. So this is going to have a scale factor of 3. So, but what we have to do is we have to then figure out. Modify this real quick. So my vertex is going to get goofy. Insert graph. Cartesian. Who left? Kid that sits there. Thank you. Darby, okay. Alright, the reason I had done this is because I know my vertex is going to be goofy on this. Alright, so it's still negative 1 and at 5. And my vertex is going to take place at 2. That's the x component of my vertex. That's halfway between negative 1 and 5 on the number line. So if I take that 2 and I plug that 2 in here and here, I'm going to get 3 times 2 plus 1, which is 3. And then 2 minus 5, which is negative 3. 3 times 3 is 9. 9 times negative 3 is negative 27. So at 2 comma negative 27 is where my vertex is going to fall. And again, yours isn't going to show that because I only gave you a positive 10 and negative 10 grid. But that takes place. What is my growth pattern? It's not 1, 3, 5 on this one. What is it?
3.
3.
9.
9. 15. And I get this because I know that's 3. So from here, I'm going to go right 1 up 3, left 1 up 3. And from there, I'm going to go right 1 up 9. 2, 3, 4, 5, 6, 7, 8, 9. And left 1 from this point up 9. And then I probably could go up 15 because I have the room, but not worrying about it. So what's special about this one is it's already broken down into 2 binomials. It's broken down into 2 binomials. That means you know the roots. The roots are where it crosses the x-axis. The number out in front dictates whether it opens up or down. Okay? The 3 out front tells you how fast it grows. How fast it doesn't grow. Okay, so these are all things we've gone over. Now, this is the first time I've given you one that the vertex is kind of way off. Okay. So, I wanted to show you make something into vertex form. Okay? So let's say I had y equals 2x squared plus 5x minus 3. Okay? Not the nicest. Our A's, B's, and C's, we know it opens up. It opens up, has a growth factor of, 2, 6, 10. Okay? But the unfortunate thing is, we need to put this in vertex form. Now, again, you do not need to know the process of going to vertex form. What you have to realize is I'm going to start giving you problems today that will be in vertex form, but you don't know how to have, you do not need, one at a time, guys. Okay? So, ready? Again, you don't need to know this process. But the first thing is you want your A value to become a 1. So I'm going to divide everything by 2. When I say everything, I mean even the y. Still with me? Look okay so far? Next step. This is the most mathematical step you'll ever come across in life. Make a space between your B and C term. Can you guys all see the space? Pretty mathematical, huh? All right. If I want to take half of a fraction, you double the denominator. So half of 5 over 2 is 5 over 4. If I square 5 over 4, I'm going to go plus 25 over 16. And I'll also subtract 25 over 16 from the same side. This is what is called the complete square. Okay? From there, it becomes two binomials. This is a perfect square binomial, meaning what two numbers multiply together to give me 25 over 16, add to give me 5 over 2. If it's not coming to you, it's okay, but it is 5 over 4. The nice thing is it is half of this. And then if I add these two fractions together, I get negative. Okay, that's going to be a negative answer. So negative 16 minus 50 over 32. So that's going to give me negative 66 over 32. And then the last step is I want to multiply everything by 2. So I have 3 terms now. Multiply everything times 2. Y equals 2, parentheses, x plus 5 over 4, quantity squared. That's going to be 16. I can reduce 66 over 16. Let's say 2 goes into those at 8, 33 over 8. So this is now vertex form, meaning my vertex is at negative 5/4, negative 33/8. Okay? Now, the ones I give you today, it's not going to be fractions like that. I'm not going to have you complete the square. This is a process that you'll see in Algebra 2. You'll go through not in one half of a slide as an instant. You'll see it as a little different rate. So you're going to see problems given to you like this. Okay? So this is already given to you in vertex form. This looks a little nicer. Watch how nice and easy this comes out. My vertex is opposite inside, same outside. Done. My vertex of this parabola is opposite inside the parentheses, same outside the parentheses. The 3 out front is the growth rate. So this will grow at a rate not of 135, but it'll grow at a rate of 3, 9, 15. You guys ready? So, graph's pretty easy. 2, negative 4. Right, and it opens up, so right 1 up 3. Left 1 up 3. Okay, from there I can go right 1 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Left 1 up 9. There it is. Okay? A lot of side conversations going on, guys and girls. It's pretty disrespectful. You want to talk, go out in the hall. Okay? If you need to, I'm happy to have mom or dad come in and sit with you so they can show you how to act in school. Happy to do it. That's an easy thing for me to do. Okay? We're covering a new concept. If everyone at 100%, I'd say talk away. Go do what you want. Well, our grades in this class range all the way, someone has a 98%, all the way down to a 4%. Okay? So I'm pretty sure there's some of you that aren't catching this right away. And if you don't pass Algebra 1, you might be promoted to your next grade level because social promotion takes place and not credit promotion because that might upset somebody. But you will repeat Algebra 1. Well, I already signed up for this. Oh, don't you worry, I can change it. It's not a big deal. You don't pass the class, you don't move on. Am I ready? This isn't going to everybody. It's just going to those who haven't learned how to act in school yet. General form of the equation is this. Does that look, let's see, I have an A value up there. Okay, I have an X, which is normal. I have a Y that's normal, but now I have H and K. I don't know why they used H and K. I wasn't at the math meeting back a long time ago when they decided, but that's why, that's the general form, vertex form. In order to find the vertex, it's the opposite inside. Can you guys see opposite value inside? And same outside. Okay? And then from there, all you have to know is A times that. Anyone want to take a shot at the vertex? Yeah, Casey. You're real close. Totally love the 6, but remember, it's opposite, so I'm going to do this. See how that's minus H? There I gave you a plus, so it has to be opposite of that. There you go. Negative 6 common 9. Love it. It's going to grow at a rate at -3 times the 1, 3, and 5. So it's going to grow at -3, -9, -15. Everyone with me on that? Let's go to the next board. Give me a paste. Cool. All right, -6, 9. -6 up 9. Opens down. Angelo, tell me how I'm going to get to the next point if I'm growing at this rate right here. Yep, over here, over 1, down 3. And I'll do the same thing on the other side, is that okay? Angelo, where will I go from there? Yep, so from the blue dots now, right? Down 9. Same thing here. Yeah, because honestly, the best thing, Mac, if you have the vertex and 4 other points, which technically means you're only, give me the gleek, I'm sorry. It's close. Means if you have this side, you know this side. If you know this side, you know this side, right? So that's all you have to do. We good? Everyone hoppy? Huh? You're frosty? Guys and girls, this something like this could be plugged into your calculator pretty easily. Okay, if I plug that in, let's see, is this going to work for me? Clear that. Y equals, what was my equation? Negative 3x? X, was it plus 6? And then plus 9? Is that right? How close can we get? Not bad for a hand drawn, maybe. I don't know. It's not blue. Okay, you're right. So that and that go are the same. That's the neater version, obviously. Okay? Again, guys and girls, if you choose, if you have that calculator and you want to, get better with it, bring it. Let's tag through these, and I'll let you use it on any of the tests. Okay? Kind of a good tool. Huh? Yeah, you want to take a picture? Yours takes a picture? Yeah. Does it really? I was going to say, that's sweet. I had no idea. Yeah. Go buy your batteries. They're 4 double A's. 4 double A's, yeah. Just, you open up that back, I don't have one with me. That back compartment open up. It's usually 4 batteries. There's a weird flat battery. That normally doesn't die on you. It's a little bit longer lasting. Does yours charge?
Yeah.
Yeah, yours has the rechargeable, so you probably can't open your back.
I mean, there's like. Yeah,
But yours can, yeah.
I don't know what's inside.
All right. So, guys and girls, I want to give you the opportunity to work the assignment. And if you need to, you can come take a picture of it. But it's going to be pages 63 and 64. And I'm giving you a nice amount of time because I want you to be able to, it's in the basket if you need to take a picture of it. It's the front and back.
20 minutes.
Well, is that okay?
Yeah.
Okay. Now Mac is like, dude, no! Keep talking, dude.